Hi students, we're looking at some log properties today. These will give you some access to solve some of the problems we haven't been able to solve quite yet. The first thing we need to talk about is expanding using the product law for logs. We mentioned that logs are exponents. This comes from the exponent property that if we're multiplying two things with the same base, we add those exponents. With logs, if we're multiplying two things with the same base, we're adding those exponents. We said logs are exponents. That's what we're adding together. For log of xy, that means we end up with log, and this again is base 10 of x plus log base 10 of y. That is fully expanded based on this property. Looking at b, we don't have a rule for adding on the inside. So that's just a trick to try to get you to think that that's the same thing, but nope, it's not. For part C, the two things that are being multiplied together are 3 and x plus 1. So we're going to have log base 10 of 3 plus log base 10 of x plus 1. For D, we have two things multiplied together, 10 and x. We could write this as log of 10 plus log of x. The cool thing that happens here, because this is log base 10, the power of 10, that is 10, is going to be 1. So I could rewrite that as 1 plus log x, and that would be okay. This is going backwards using the same type of thinking. So if we're adding things, that means that's the same as multiplying things inside of a log. And we can write that as log 3 times 4, or if you wanted to, log 12. Remember, this is log base 10. For the second one, we've got log of 2/3. We're adding. So we're going to multiply things on the inside. And if I were to simplify that, we'd get log of 1/2. For the next one, we've got log of x squared plus log of x cubed. That's going to give us log of x squared times x cubed, which is the same thing as saying log of x to the 5th. And for the last one, we're adding these things, so we're going to multiply them on the inside. We've got log of x plus 1 times x minus 2. The second property we're looking at, again, this is based on properties of exponents. If we're doing a to the m divided by a to the n, so the same base of our exponents being divided, we subtract those exponents. Same thing is happening here. We've got stuff on the inside being divided. We're subtracting those exponents because logs are exponents. I'd like you to notice that b is another nope. It's not about subtracting on the inside, but dividing on the inside. Our first one is going to be log x minus log y. Our second one is going to be log of x plus 1 minus log of 100. And since this is base 10, what power of 10 is 100? That's going to be 2. So log of x plus 1 and then minus 2 on the outside. For the last one, we've got log base 3. This is really important. You've got to keep whatever base you start with. So when we do this, all of these pieces are going to have log base 3. So log base 3 of x, and then minus log base 3 of 3 times x plus 1. And here I notice something else. I'm multiplying two things on the inside of this. So I could separate those as well. And I'm going to have minus log base 3. I'm going to put this in parentheses of 3 plus log base 3 of x plus 1. So I separated those using the rule from the previous page, and now I've got this expression where it's log base 3 of x. The power of 3, that is 3, is 1, so I can write that as minus 1. That minus can get distributed to the other one, minus log base 3 of x plus 1. Condensing these, our first one, we're in log base 10, and I'm going to do this as 12 over 4, which is 3. Second one is going to be 1/3 over 2, which is weird. You could also write that as 1/6 because we're dividing a third in half. For our third one, it's going to be x to the 5th over x squared, which is log of x to the 3rd. And then for our last one, we have a couple different things to combine. I like to do these in kind of a shortcut. Look at my bases. Okay, base 10. I'm going to make a big fraction. And stuff that's positive is going to go on the top, multiply together. So that's going to be 2 times x. And stuff that's being subtracted is going to go on the bottom. And that's the x plus 3. Our next law of logarithms is going to be our power law. And just like the other ones, this is based on an exponential property. So if we've got a to the m to the n power, that's the same as saying a to the m times n power. In logs, if we've got a power raised to a power, it's the same as multiplying that power n by that other power, that log. Shortcut way of thinking about this is that we are bringing this power down front when we're expanding this. So if we're looking at log of x squared, that power comes down front, becomes 2 log of x. This is another, nope, this is not what this is talking about. That power is on the outside of that log. That's why we can't do that. Looking at c, that power is going to come down, 3 log x, and that power is going to come down 4 log x, and we can combine those. Those are like terms to give us 7 log x. For d, I'm going to do the same thing, bring that power down, a plus 1, and then log of x. We're going to do the same thing but work backwards this time. So if we have a number out front, that's going to go up top and become 3 as an exponent. So it's log of x cubed. Same thing for the next one. That 2 is going to go up top. That becomes log of x minus 1 squared. Same thing for the third one. This is going to get messy. I'm going to have 2x squared in parentheses, and then to the power of 3. For our last one, this is asking us to combine. It's giving us 2 different steps. I'm going to do this 2 different ways to show you kind of stepped out, or doing this all in one step, whichever one you prefer is okay. My powers are going to go up top. This becomes log x to the 5th minus log x to the 3rd. Minus means I'm dividing. So that becomes log of x to the 5th over x to the 3rd, which is log of x squared. Another way of doing this is kind of doing everything at once. We know we're going to have a log expression that's set up as a fraction. The positive one's going to go on top. That's going to be x. That's its power. The negative one goes in the bottom. That's going to be x on the inside. The number out front is its power. That gives us the same thing. And if you're okay with those shortcuts, that's a fine way to do that as well. There are a couple other exponent rules that apply to logs that we just kind of have to work with. The first thing we have to know, and this is based on our graphs, logs have the domain x is greater than 0. That means that you can't take a log of 0. You can't take a log of a negative number. I don't know what I was writing there. I meant to write nope. Log base 2 of 1, well, we've talked about that. What power of 2 is 1? Now we have a property to talk about that. The exponent version of this would be saying that b to the 0 is equal to 1. The log version is saying that any base of 1 is going to be equal to 0. Log base of itself, what power of 4 is equal to 4? That's going to be the first power. And then we have a couple of properties that are based on inverse functions. If you have a base raised to log base b of that power, that cancels everything out, and you're left with just that x. The same is true if you take the log of that same base. That leaves you just x as an answer as well. These are really important in terms of solving more complex equations, like some of the ones that we couldn't solve a few minutes ago. And by a few minutes ago, I mean the previous video.